Okay, second half Madhu madam is going to take. Finalized. Okay, I hope everybody has joined. Still MCQ, but you have to think. Okay, that's why I did not say that अभी 10 क्वेश्चंस कर दिए हैं तो सिर्फ 15 मिनट दूंगी, ऐसा नहीं है. You'll get 20 to 25 minutes approx. Okay, not full 30 minutes. You'll get 20 to 25 minutes approx to finish up that. Okay, once that 25 minutes is over, okay, I will stop my responses. So you have to keep the tab of time. मिड सम की तरह ऐसे नहीं रखा है कि एक क्वेश्चन चेंज हो गया. ओके, वो टाइम मैनेजमेंट आप पे रखा है, बट यू आर गोइंग टू गेट अप्रोक्स 25 मिनट्स, उससे ज्यादा नहीं, क्योंकि सिर्फ 10 क्वेश्चन है. 10 क्वेश्चन के सामने 25 मिनट दे रही हूँ. ठीक है, और अगर सही तरीके से पीपीटीज वगैरह या तो कोई ये जो बुक्स है जो मैंने ऑनलाइन बुक अपलोड की है सही तरीके से अगर समझा होगा, आई एम नॉट सेइंग पढ़ा होगा, आई एम सेइंग समझा होगा, तो क्वेश्चंस बहुत इजी लगेंगे. लेकिन रट्टा मारा होगा तो फिर क्वेश्चंस थोड़े टफ लग सकते हैं. Okay, I'm starting with the session now. See, we are going to study for half an hour today. Okay, I'm going to take 1 hour of the session. Half an hour we are going to study. For the rest half an hour you have your test. Okay, from 10:30 or maybe 10:35 onwards, Madhu ma'am shall join the session and she'll continue for the next half an hour. Okay. See, we had started with her doubly linked list in our previous session. We did start with this doubly linked list. Okay, we had discussed what is the structure of doubly linked list. If I want to identify that this is my doubly linked list, okay, the given picture is my doubly linked list, how can I identify that it is my doubly linked list? What are the properties, or you can say the key points of your doubly linked list? Can anyone tell me? How can you identify that it is a doubly linked list? 2 pointers, yes, absolutely right. What about those 2 pointers? Any specifications regarding first node and last node, anything like that? Previous and next, yeah, that is considered in 2 pointers. One is going to point to the previous node, another is one is going to point to the next node. But what can you say about the last and the first node? The previous of first node will be null and the next of last node will be null. Okay. first and the last node with the are not null. The node pointer previous of first node pointer of node pointer next of last node will be null. Okay. So we had seen what is a doubly linked list, correct? The theory portion. Okay. This is the logical representation. We had compared it with our singly linked list logically. Okay. I also told you how you can write the comparisons between the singly linked list and doubly linked list. We had discussed that node structure. The node structure, one more addition of your pointer. Okay, till date you were having two data member variables, right? One was the data part and another was the pointer part. Now there is one more pointer called previous. Okay, along with integer data and struct node star next. Fine. So this is the structure node. Now onwards, when we are doing the practicals of doubly linked list, then structure node, when you go and create the structure for the node, you have to create it like this. Okay. We are going to start with advantages, disadvantages, and cases of insertion. Okay. So what is the advantage of doubly linked list? Why programmers or the one who developed the languages why they developed this doubly linked list? Okay, for the traversal purposes on either direction. Okay, till date in singly linked list we were able to traverse in one direction. Okay, again then we came up with a more advanced variant that was circular linked list, so we can go in a circular manner from last to first, but that was also in a in a single way. Okay, you cannot go back, but here you can go back. So on either direction for the conveniency, okay, the traversal in either direction, that's why doubly linked list was designed in such a manner. Then reduction in operational time. How can we say that there is a reduction in operational time? See, if you want, if your rear is at third, okay, is at third position, third index, okay, and you want to go and update the second value, then using your previous of that third, you can go to the second and update or do the operation. You don't have to, go till the last, then again come back to first, then again 1 and 2. Okay, like that you don't have to go. You can use your previous links and directly reach your targeted node to do your operations. Okay, so that reduces your operational time. Then it can represent the other data structures. Okay, doubly linked list, you are using it in in trees, in heaps. Okay, it has its application in representing those other data structures. Now the disadvantage. Okay, every coin has two sides. Okay, so there are not only just advantages, but there are disadvantages too. What are those disadvantages? It needs extra space. Why? Because you are maintaining two pointers now, right? So compared to your linked list and circular linked list, it is going to need extra space to store that one more pointer. Okay. While you are manipulating the list, okay, you need to take extra care to manipulate your links. For example, if you are adding the node in between, okay, or you are deleting a node in between, then you have to take care of two links, that is previous and next. And previous and next of whom? Between those nodes which you are updating, either deleting or inserting. Okay. So ideally, you have to make around 3 to 4 link updation, and you have to take care while manipulating those links. You have to take care that you do not make mistake. Okay, so that is one of the disadvantage. Now we are coming to the insertion cases, okay, of your doubly linked list. What are those insertion cases? The very first one is you have to insert a new node, okay, a new node in your existing DLL in the beginning, okay. Then insert a new node at the end, then insert a new node after a given node. So user is going to give you that after this particular node I want to insert. So there you have to insert your new node. Similarly, before a given node, you have to insert a new node. Okay. And case 5, it is inserted in the sorted linked list. Okay. So these are the 5 cases. We might finish 2 out of these. Okay, let's see. See, this is the diagram way. Okay, is it visible to all? Okay. See, whatever content is written in black, that is your existing singly linked list. Whatever content mentioned in red, okay, is the updating part. Fine. Now see, logically, just see, understand it, then we'll go with the algorithm. I have a doubly linked list, okay. The head pointer is pointing to a node which is having memory address 1000. Fine. The first pointer, because sorry, the previous pointer, because this is the first node, okay, the previous pointer is null, which is represented by x. The next pointer is having the value memory address of the second node. What is second node memory address? 2000. So 2000 is written here. Okay, I have a forward link, I have a backward link. Backward link pointing at 1000. Why? Because the first node memory address. Okay, similarly at the second node, next pointer I have value as 3000. 3000 is the value of my third node, and previous of that 3000 is having value 2000. Okay, so that I created a forward link, I created a backward link. Okay, and 3 is my last node, so next pointer represented by null. Okay, now there is a new node with memory address 4000, and I want to add this node at the beginning. Okay, so see what all changes I have to do. First of all, because this node is to be inserted at the beginning, it is going to be your first node. Now what my property of DLL says, that first node in the DLL previous should be null. So this portion, this previous of my new node, I am giving value as x. Okay. Now the position of this new node should be first. Okay. So I have to update my head, I have to update my previous, and I have to update my next of my new node. So first of all, updating the links of my new node. So for previous we are done. Okay, previous I gave null value. Fine. Now for the next, here next part, I am going to give new node next equal to head. Why head? Because head is storing value 1000. I want this new node 4000 to point it at 1000 to create a forward link. Okay. So new node next equal to head, because head is storing value 1000 right now. Okay, so this link, this red link got created, forward link. Okay, now what I have to do, I have to update my head. Okay, I will move my head, yet I have not updated this. Okay, I need to first of all, wait, you can just update this one, sorry, my mistake. Head of previous. Okay, right now my head, come back again, new node next equal to head, done. Okay, so forward link created. Now I have to create this backward link. Okay, this one where my arrow is pointing at, this link I need to create. Okay, which is my backward link. So how am I going to access this previous? With the help of head, because head is pointing at 1000. So head of previous, I can access this part, right? So head of previous from null, I am going to update to new node. What is new node value? 4000. Okay. So what you are going to write in the algorithm? Head of next this part, head of next, is equal to new node. So that is 4000. So we created this backward link. So forward link and backward link created. Now what I have to do? So basically what I can tell that this node has been placed here in the DLL. Now satisfying the property of DLL, head should point to the first node. So we are going to update that head value from 1000 to 4000. Okay, so head is equals to new node. Once again, you are creating a new node. New node memory we got as 4000 using your malloc. Okay. Now new node previous, because we know that this node is going to be placed at the very first. It is going to be a very first node. So previous we did as X. Okay, X means null. Now for the next, new node next equal to head, because head is pointing at 1000. We need to create a forward link with this one. Correct. So new node next equal to 1000. So this red line created. Now I have to update this part, because this whole node is now going to be my system. Okay, so I need to create a backward link. So who can access this part? My head. So head of next. Okay, updating that value from null to 4000. So head of next equal to new node. Okay, so this backward link got created. Okay, so basically this node got placed here in front, but head is still pointing at 1000. I need to satisfy now the property of head value from null to 4000. So head of next equal to new node. Okay, so basically everybody understood this diagram, this logical way. Now let's see the algorithm. New node to be inserted at the beginning. This is the case for your doubly linked list, DLL. Okay. So first of all, your common first three steps for allocating the memory to your node. Okay. So 1, 2, and 3 are going to remain same. All right. As we have seen in our previous cases also. Then you are going to give the data part of your new node, some value you are going to give to that new node. Then what you are going to do is, first of all, update your new node previous. New node previous will be pointing towards null. Okay. Why we are so sure about this particular value? Because this node is going to be inserted at the beginning. And we know that the node at the beginning, the very first node, previous part is null. See, I'm repeating this again and again so that it gets hardwired in your brains. Okay, you don't need to come and memorize it. That's why I'm repeating this again and again. So new node previous is equals to null. New node next is equal to start. So we created that forward link. Okay, so new node next is equal to start. Fine. Then we are now updating the previous. Okay, so start previous. So in the diagram, the value which was previously null, okay, the original first node previous value, we are updating it with new node. So start of previous is equals to new node, and we are moving our start backwards to the already to the now our first node. Okay, so start is equals to new node, and you are going to exit from the function. All right. So total you can say 4 links are getting created or updated. Fine. See, when I say just updated, then you have to consider just 2. Okay, that is step 7 and 8, because they are the links which are getting updated. Okay, but if I say update dash or update slash created, then it is 4 links. Got it? Any doubt in this algorithm? Anybody? Others? See, you have to do practicals for these also, okay? Even if we don't cover all the cases in the practicals, I'll give you some, practice session on these cases too. Okay, so please try to understand, try to grasp how the logic, how the steps or flow of the algorithm is going. Okay, and that's why I'm keeping the diagrams as many as possible. Fine. We can see one more case, and then I'll circulate you the test forms. Insert the node at the end. Okay. First we inserted at the beginning. Now we are going to insert at the end. So again the steps remains the same. The first 3 or 4 steps till the data part. Okay. The first 3 steps handled by your malloc for memory allocation part. Once the memory allocates, you are going to give some value to the new node data part. Now we have to insert a node at the very end. Okay, so we are going to need a pointer too. So first of all, as we did for new node previous, here we know that this node is going to be placed at the end. So we are very sure that new node next value is going to be null. Okay, so we are directly, giving that value, new node next equal to null. Okay, because of the surety we have that this node is going to be at the end. Now we are going to take a pointer, okay, another pointer, PTR, temporary pointer, and we are going to traverse it. Okay, traverse it in our doubly linked list so that it reaches the last node. Okay, so what is the condition for that? While PTR of next is not equal to null. Alright, in your existing doubly linked list, there is a last node whose next pointer is null. So till that point, we need to reach that last node. So while your PTR of next is not equal to null, till that time you have to move your PTR with the help of the code PTR equal to PTR of next. Okay. Once it reaches the last node, you are yet to insert or add that new node in the list. Okay, once it reaches the last node, then what you need to update first of all you are going to update this PTR of next, which is currently null. We don't want it null now, we want it to be pointing at new node. Okay, so PTR of next is equal to new node, so forward link created. Fine. Then we also need to create the backward link also. So new node of previous is equals to PTR. So two forward and backward link created. This new node next, we already gave it as null value. So you don't need to do anything with new node next. Okay, and so thus you are going to exit from the function. So basically what you are doing here is you are going and creating a new node. Okay. You are very sure that this node is going to be placed at the end. So directly after giving the data of that new node, you are giving the value null to the new node next. Okay. Then to place this new node, to make it a part of your existing DLL, you are taking a temporary pointer starting from the head. Okay, and you are traversing that pointer inside your existing DLL with the help of a condition that until your PTR of next is not equal to null, this PTR should move forward. So you are using a loop where you are giving the condition PTR of next not equal to null, and inside that while loop you are executing the code PTR equal to PTR of next. Once PTR of next is equal to 0, that means inside your existing DLL you have reached the last node. Fine. Now after this last node we need to add our new node. So for what we are going to do, we are going to update that null value of the last node. So PTR of next is equal to new node. Fine. So we created the forward link. Now from new node we need to create the backward link also because this is DLL. So new node previous is equal to PTR. Okay. New node next is already null. So our DLL is ready, and you can say that new node is inserted at the end. So that's why you are going to exiting from the function. Okay. This is how the algorithm for new node at the end is working. Understood? Okay. We are going to keep it till here. Two cases. Okay. From next session, we are going to see your other cases, that is case number 3, 4, and 5. All right. I am going to circulate your unit test Google Forms in your respective emails. Refresh your email when I say. Okay, students, refresh your Gmails. You must have received one form. Everybody has received it? Yes or no? Okay. So you may start answering in that Google form. It is 10:03. Okay. At 10:30, exactly at 10:30, I shall stop the response collection. Okay, so you have to manage your time. Keep a tab. I'm telling in my watch right now it is 10:03. Exactly at 10:30. I shall stop the responses. So you have to see that before 10:30 you are submitting your responses. Don't submit at 10:30. And remain in the meeting. Okay, do not leave the meeting. Yes, Raj, any issues?